In this video we're going to take a look at some of the challenges from the DeadFace CTF 2021. It's hosted by CyberUp, Hacktics and United States Air Force veterans and supported National Cybersecurity Awareness Month. And in the past couple of videos I've just picked a category and focused on that for the video, but the average difficulty of challenges in this CTF are quite a bit lower than the last couple of CTFs that I've run through, so I'm going to aim to just kind of run through as many challenges as I can here from some different categories. I am going to purposely leave some out, for example cryptography, but yeah, let's get started. The first challenge we're going to take a look at is called Unfinished. It's a programming challenge and the description says, there seems to be something wrong with this code, can you figure out how to make it return a flag? And it's telling us to modify the code that we have here, which we can see we've got this little Python script. Before even really looking at it, let's go and create a Python script. I'm going to open this up in Codium or VS Code, but you can do it in your text editor of choice or IDE of choice. And we open this up, we see that we've got this print statement, so this is going to be executed. This function getFlag is never actually being called anywhere, so there's nowhere in the code that this is being called. So we would need to actually say we want to call getFlag in order for it to return this value. So we could say flag is equal to, and then it's basically going to call this function, it's going to decode this string, as you can see here, decode UTF-8, it's going to return it into this flag variable. But we don't even need to create that variable, right? We're printing the flag here, so we can just go and say plus get flag, and that should print the flag for us. Let's try and run it. And there we get flag. Oh look, it's a flag. Obviously, whenever we looked at the challenge there, the first thing we should have seen really was that the flag was hex encoded based on the character range which is being used here. So rather than actually copying over and modifying the code, we could have just taken that to CyberChef to decode, or you can do this you could do it in Python. If you have pwn tools installed, you can just do pwn unhex and then paste that in, and then you'll get the flag back in the terminal. The next challenge is called the count. It's a programming challenge, and the description says, apparently DeadFace is recruiting programmers, but Spooky Boy is a little apprehensive about recruiting amateurs. He placed his password hash in the form of a flag for those able to solve the challenge. Solve the challenge and submit the flag as this format with the SHA-256 hash. There's a forum thread here, but it's not really necessary. Let's just grab the server address and the port number. You can see I've got my script there for solving it. Let me just try and connect to this with Netcat and see what's going on. And you can see that we get this message saying, DeadFace Gatekeeper, let us know how good your programming skills are. If A equals 0, B equals 1, C equals 2, etc., tell me what the sum of this word is. So it gave us the word cumbersome, and essentially we need to find out that C is equal to 2, U is equal to whatever, add it all together, and we need to submit that within 5 seconds. So I wrote a script to do this. I was actually expecting that whenever we run that, I was expecting it to ask you to do that several times, maybe ask you 100 times what's the sum of this word, but it actually doesn't. It only needs to be done once. So this is the script that I put together for it. I'm importing pwn tools as I usually do, just to make things easy in terms of connecting to the remote server and sending and receiving data, and also using debug statements and stuff, which I like doing. But let me just run through this. So we connect to the remote server, got the level set to 1 here just to reduce the output in the terminal, and we wait until, well, we receive everything. Let me just run that again. We receive everything up to your word is, and then we then want to capture the word. We're going to print it out to make sure we've got the word correctly, and then we're going to run through. You can see we imported string here, so we can actually use string.asciiletters.index and then loop through each char, and that'll tell us whether it's the 0th element, the first element, the second element, etc. And we're going to add all those together into this sum variable. We're going to send that off as a string, and then we're going to receive our flag. So I thought we were going to have to put this inside of a loop and just loop through like 100 times doing this to get the flag, but apparently we don't, so it's quite a bit easier than I was expecting. But let's try it out anyway. We'll run Python exploit, and the word we got was lace. We could have probably actually calculated that within 5 seconds and submitted it, and then we got back our flag. The next challenge is called Trick or Treat. It's a programming challenge, and the description says, a user on Ghost Town created a game that he claims no one can beat. Check out the game and find the flag hidden inside. So we've got a zip file to download, which I've already got downloaded here, and if we have a look at the files that were downloaded, we've got a Python script, we've got an image directory, and we'll take a look at those. We got this font file in here, we got an image directory just with a player and a enemy, and then we've got our script. So let's open that up. And immediately we'll see that we have some hex values here, so we might want to go and try to decode those in, we can use unhex in the terminal, or we can go to CyberUp. If you are used to seeing flags in hex, you'll know what the beginning of this string is, so we can do unhex here and see that it actually begins with flag, but in this case it's just a fake flag. So we can keep going through in this fashion and having a look at some of these hex values just to see if it's just a case of decoding and see what these are. I think some of these point to like block and stuff like that, unhex, death and block, and basically different actions that are occurring. We also have some decimal arrays here, so we could go to CyberUp and convert these from decimal. Set this to comma, although it doesn't seem to be making a difference. But notice that it's not just printing these decimal values out here, it's actually using the set pref and is calling another print function here with some more decimal values. And this print value, this is a custom function which is actually using these hex values here. Unhex, okay. I think that's because we're don't think that was correct. Yeah, because this is the alphabet. So this is the alphabet that it's using here, and it's like a custom print function. So let's go down towards the where the program starts anyway. We've got our main functionality down here at the bottom. It's going to basically set up the game for us. It's going to initiate the game. Let's play it as well. You can run Python game. You need Pygame installed, so you can just do pip install Pygame. And basically you have this character. You need to try and avoid as many of these enemies as possible. They'll increase in speed and frequency. I'm pretty sure that didn't hit me, but okay. We can hit P to pause, and that's it. You notice it printed this flag in the background, but it didn't print any more of the flag. And so basically what I would do here is go and try and focus on anywhere that we have print, so go and search around for these print functions and see when are they actually called. Remember that we had this GS function with these weird, there's no real reason for those values as far as I can see. So we have this escaped GSS. Notice we have this here as well. So the only time that GS function is called, as far as I can see, let's double check. It's called, it's called here and it's defined here. So the only time it's called is whenever this condition is met, which is to do with the speed of the enemy. So once they get up to a certain speed, it's going to pause the game. It's going to set the pause text to this, and then it's going to pause the game. So what I'm going to do is I'm just going to take this here, and before we've even spawned a player, let's call that instead. Sorry, before we've even spawned an enemy. Hit go, and there we go. So we can see that our flag is just repeatedly printing in the background. Pause now crashes the game, but that's fine, we've already got our flag. The next challenge is called Blood Bash. It's a forensics challenge, and the description says we've obtained access to a system maintained by Bloody Mary. There are 5 flags that we need you to read and submit. Submit the contents of flag1.txt. So this is a 5-stage challenge where we've got access to this server. You can see it's on port 22, so it's an SSH server. So let's SSH as Bloody Mary into this server address and port number. We don't need the port number because it's the default. Try and connect. It'll ask us for the password then. And then we're connected. Note that whenever I was actually trying to do this originally, I got an error with the TTY, and I had to use the -T flag whenever connecting SSH for that to work. But we're connected now, we're able to access the server. Let's see what we actually have here. We've got this PDF file, which unless we have some kind of PDF reader, we're not going to be able to open here. Let's try and list -R, so we'll capital R to recursively list all of these directories. And whenever we do that, we'll see that we've got a flag1.txt file inside documents. So let's just say we want to cat out documents flag1.txt, and there we get back our first flag. Next up we have bloodbash 2, and it says we've obtained access to the system maintained by Bloody Mary. We believe Bloody Mary stole a sensitive document and is storing it on a Linux machine. Search the system for any files relating to Demon Financial. So we're already connected from the last part of the challenge. Let's go ahead and try to find this. What I did here was just find, and I literally just copied and pasted the string that they provided, and then just search for from the root directory. You'll see we get a lot of errors here, and this might take a second to run through, but hopefully when we get to the end, and what I just noticed here was that we have this daemon info in the documents as well. So it has a dot at the beginning of the file name, so it's hidden. So if we go into documents and ls, we're not going to see it. Let me see if we do ls-lart, we will see it. So it's a hidden file, but we can still go ahead and print it out. There was probably a better way to find that without getting all these errors, but that just happened to be the first command that I tried, and I found that hidden text file. So that's the bloodbash 2 flag. On to the next part of the bloodbash challenge. We have the third part, and it says there's a flag on this system we're having difficulty with. Unlike the previous flags, we can't seem to find a file with this flag in it. Perhaps it isn't stored in a traditional file. So let's jump back over to the server again here. I'm going to go back to the home directory, but what I did here was to run sudo-l, and you can see that we actually have some commands that we're able to run as sudo. We have this start script, and then we can also run this serve as sudo as well. Let's try and, first of all, if we just try to cat out that serve, you'll see that we get permission denied. Let's try and cat out the start script. And we can see here then, if we run the start script as sudo, it's going to run sudo user bin serve, and then it's going to exec bash. Let's just try and run sudo opt start.sh. Address already in use, okay, hit Control and C, and now you'll see that we're actually root. Let's try and cat this out again. And this time we're actually allowed to print out that user bin serve, and if we do that we can see that we have a hex value in here, which from our earlier challenge you'll know that we can just jump over to our terminal and say pwn unhex and then paste that in, and then we get back our flag, which is flag open port uls. On to bloodbash 4, and the description says a sensitive file from daemon was exfiltrated by Morticia. It contains data relating to a new web portal they're creating for consumers. Read the contents of the file and return the flag as flag goes here. So we had that PDF file, didn't we, in the home directory, which we might want to try and recover. Let me just try and see. Initially I tried to SCP this and it didn't work, but I think that was to do with the TTY error, which they seem to have resolved. So let me just try and move this daemon customer portal to new.pdf, just so the file name is a bit easier to work with. And I'm going to go back over to my terminal and we'll do scp. Let me go and copy this name and port number again. So we want to grab it from Bloody Mary at this server address, and the file we want to grab is just new.pdf, and then we'll just place it here as well. Try and run that. Let's see if it asks for the password. It does. Okay, so we now get this. This was the message I was getting whenever I tried to connect via SSH, and I got around that by using the -t flag in SSH. If we do man SSH and scroll down quite a lot, eventually we'll see the -t flag in here for sudo terminal allocation. This can be used to create arbitrary screen-based programs on a remote machine, which can be very useful. So this is how I was able to get SSH working earlier. I'm assuming that was, an issue with the challenge, because it doesn't seem to be the case now. But alright, that still didn't work for us. Let's go back over to the system here. Another thing that we can do is we can say we want a base64 the new.pdf file. we can go and take a copy of this base64 encoded value, and we could go and base64 decode this here. In fact, yeah, let's do it here. I was going to go over to CyberChef, but we'll be using that a bit later. So let's go and create this file, paste this in here, and we want to say base64-d to decode, and see that is creating the PDF as it should. So we'll say we want to pipe that to new.pdf, and let's go and open the PDF and see what's in it. Open the PDF, and there we get our flag. The next challenge is called Window Panes. It's a forensics challenge, and the description says one of the Demon's employees had their personal Windows computer hacked by a member of DeadFace. The attacker managed to exploit a portion of the database backup that contains sensitive employee and customer PII. Inspect the memory dump and tell us the Windows major operating system version, bit version, the image, date and time, and then submit it in this format here, and we've got an example of how to format it. So I've already downloaded the image. You can see here you've got to download it and decompress it, so I've gone ahead and done that. Let's jump over to the image now. We can have a look at this physmem_raw. It just shows that it's data, and typically what we do here is use volatility to find out what operating systems, what profile basically we need to use to run different plugins. So let me just go to volatility. We can open up the help menu here and get a list of the different plugin commands that are available and the syntax that we need to use. But essentially what we'd normally do here is say volatility and image info-f and then physmem_raw. I did try doing this, and it took a long time and didn't come back with anything. And at the time I went and did a little bit of googling around that and seemed to find that it looked like it was to do with the volatility that I have installed on Parrot not having some of the Windows 10 profiles that are needed. So I did actually try to download volatility 2 from GitHub and set that up, but I had a lot of problems. I always have a lot of problems with Python. Anything that's running Python 2 seems to cause a lot of issues for me. In the end, what I had to do was move over to volatility 3. So let me just grab a copy of that. I'm going to grab this from GitHub and install it. So git clone. Let's go into volatility 3 and see what we've got here. I'm going to do sudo python setup install. Let that run through, and that should be us installed. You can find some good cheat sheets online if you just search for like volatility cheat sheet. You'll find some good ones on here. Hacktics, if page not found. Oh, okay, it's redirecting. So Hacktics has a cheat sheet here and gives you some examples of different commands that you can use. You can see here it's set up for volatility 2 and volatility 3. So whenever you're running through some of these different options, for example, say you know that the challenge is asking you to get some passwords, you go straight down to the hash password section, click whichever tab depending whether you're using volatility 2 or 3, and this will give you the different commands that are available. It seems to be having some difficulties, but there are plenty of other cheat sheets out there anyway, and even the reference guide available from volatility themselves is probably the best option. Let's go to the wiki here, volatility 3 documentation, and yeah, you can also jump in here and find some good information about the plugins. But let's go and try and solve our challenge anyway. So the first thing that we want to do here with volatility 3 now installed, let's do python vol.py, and I'm going to pass it in that image again, // You don't get autocomplete for some reason with this, but let's just type it in. And then let's just try and run this first of all and see what it says. Just says select a plugin to run. Okay, let's try and do windows.info. Oh, by the way, another reason I actually noticed that, so I was kind of just looking at the strings here. If we run strings on physmem_raw, and well, let's first of all, what I did notice, if we grep out flag whenever we run strings, we get back quite a few results, I guess, of fake flags. You can see here flag FOD check, and you can see it's been set here as a variable. We have another one, Jimmy got pwned. So maybe these are from other challenges or challenges that are going to be released later in the competition, we'll see, but these weren't the correct flag anyway, because obviously we're looking for the operating system, the version, the image date and things like that, which hopefully this will come back with. Okay, so it took a little while to get through all of that, but now we've got back our Windows information and we can see some various things here. So we can see that we have our major operating system version is 10, so Windows 10. Oh, that's the other thing I was going to say here. If you grep here, I was grepping for, did I grep for Windows 10 or Win 10 or something like that, and I was getting quite a lot of results, and that's kind of how I identified that it was probably an issue with the profiles in Volatility 2 that was causing me issues. But yeah, we've got our operating system, which is 10. We've got our system time, so this is the time that the image was captured at, which we know is what we need. So basically we'd be putting together our flag here. Our flag is going to be Windows 10, and then the architecture is 64-bit, and then we want our timestamps, so it would just be 2021 0907 14 57 44, and that would be the correct flag for this one. So following on from the last challenge, we have window panes 2, and the description says, using the memory dump from window panes 1, submit the victim's computer name. And if we go back over to our cheat sheet, or well, our cheat sheet keeps crashing, so let's just go over to the actual reference here where we can get a list of the different plugins that are available. You can see here's Linux, here's Mac. They're going to be no use to us. What will be of use to us is these Windows plugins. So we can go through, we can have a look at some of these. In this case, I kind of just ran through a few of these common plugins to check. In this case, we've got this windows.envars where we can actually print out the environment variables. So let's try and run our, let's run this again. Instead of doing Windows info, let's do envars. Oh, wrong. You can see as I typed that in incorrectly, we actually managed to get out the suggestions of the plugins as well. So that's another way you can kind of get an idea what, if you're not too sure what plugins to run, you can just kind of go through and run whatever sounds interesting. So we run through all that anyway, and you'll see one of the last things that we see here is the computer name, desktop IT8QNRI. So our flag is literally just going to be take that and then flag, oops, not quite that, but yeah, you get the idea. And onto window panes 3, it's asking us to use the memory dump file from the previous challenges to find out the name of the malicious process, and they want that submitted as flag process ID, including the extension. You'll note that I got very close to where's the solves, 4 out of 5. So I kind of misread this. I thought it was asking, I wasn't sure whether it was asking for the process name or the PID, because it says PID. I thought it was just saying process ID here, and then it was like asking for the file extension. So I was a little bit confused with that, but once we got the format sorted out, it's not too bad. Let's go back over to our volatility, and there are a few things we can run here. We can run something like PS list, we can run PS tree, we can run PS scan, and they'll all do slightly different things, which we can go and find out about here. You can see here PS list, PS scan, PS tree. I think PS tree is the one that shows you hidden plugin for listing processes in a tree based on a parent process ID. So we can run through those and get an idea of some of the different processes that we have running here. So it might just be worth scrolling through and seeing if any of them look suspicious. And if you find any that do look suspicious, we can basically go and dump those out and see if there's anything more suspicious. So here we have the process ID, for example, of this WinP, Mem, Mini, etc. Let's try and run a, instead of PS list, we can run dump files, and then we can pass in the process ID of the process we want to dump the files for. We run through this, and you can just have a look at what files come out. Do any of them look interesting? We might want to go and actually look at the strings in the exe, or open up the exe in Geardra or something like that to have a look at it. In that case, that wasn't the one I was looking for. Let me, instead of PS list, let's do PS tree or PS scan. Alright, so PS tree, you see this one brings back another one that we didn't see last time, which was userinit.exe, which immediately sounds suspicious to me. So let's take a copy of that process ID, let's dump that out, and we dump that out. I didn't really look to this into too much detail. I saw a mention of this crypt SP and bcrypt primitives, and just to me instantly sounded like it was probably potentially malicious, and submitted this process name with the PID. So just to confirm, the flag is, it is flag process ID underscore 8180 for the process ID. The next stage of the window panes challenge is asking us to get the SHA-1 checksum of the malicious process. So we've already extracted the malicious process, or we already had a look at it. We just need to actually go and dump the file and then find out what is the SHA-1 hash of it. So let's use our Python volatility again. We're passing in this raw memory image, and then we're going to say -o for an output directory. Just say that's going to be the directory we're currently in. We're going to do windows.dump files, and then we're going to set the PID to 8180, which we identified previously, and that's going to dump out all of those files that we saw associated with the exe. So not just the exe, which we'll see up here, but also all of these DLLs and stuff that were associated with it. But we know that we're interested in getting this exe SHA-1 sum. So we'll do SHA-1 sum, we'll provide the file name, and then we get back our hash. So all we need to do is go and submit that with the flag parameter. The next challenge is called File 101. It's a forensics challenge, and the description says, an email containing a photo of a pumpkin was found in the employee's Gmail inbox. The photo looks normal, but can be deceiving sometimes. What secrets could it be holding? So we've got this image to download. It's a JPEG image. You can see it here. It's just a picture of a pumpkin. And I'm trying to think what I did here at the time. So let's try and run strings on it first of all. We can look for strings greater than 10. And we have this URL in here for this Dropbox. So let's go and open that up. Open this up, we have a corrupted.zip file, and the file name is 40x PNG, 421 kilobytes, nearly. Let's try and get a direct download of this. I'm going to save it, and let's move it from downloads here. Let's try and open up corrupted.zip, and it asks us for a password. So let's well, I'll just try and put in here password incorrect, admin incorrect, password 123 incorrect. Alright, so what we can do is try and crack the password on this. We can use zip to John on corrupted.zip, and this will create a hash format that we'll be able to crack with John the Ripper. So let's run that again, and this time save it to hash. So it's in a file called hash, and now we can run John. So let's run John -- word list equals user share word list rocku.txt, and then we want to pass in the hash. We run that. Oh, is that okay? I already had this still in the. Either that cracked really quickly, or I already had it in a pot file. But yeah, you can see that it cracked there as pumpkin pie, and that means we can go ahead and unzip corrupted.zip, enter in pumpkin pie as our password, and now we get out this PNG file. So we can try and open this up. Although you notice that the thumbnail isn't showing anything, so that's not a good sign. Open it up, and then we don't get anything. So we could try and have a look at the strings again. Nothing of interest. We could have a look at the EXIF data to see if there's anything hidden in there. Nope, it's a PNG file, which you can use some stego tools like zsteg for, but I mean, this isn't a stego challenge, so you wouldn't really expect it to find anything. And we get unsupported header. Alright, let's actually use hexedit to have a look at the header. And if we go and have a look at that, you'll see that we have this jfif in here, but it's starting with 2E2E78, which doesn't sound right. Let's go and have a look. What is the JFIF file signature? And if we go and have a look at this here, we'll see that actually this should be beginning with FFD8FFE0. So let's go and set that FFD8FFE0. Let's save it. Let's exit that. And now let's try and display it. This opens up. Now it's quite funny because I spent a long time on this challenge and for some reason didn't actually see the flag. Let me see. Okay, so whenever I was initially doing this challenge, I had the view something like this, and I was quite confused because it looked to me like it was displaying the image, and obviously it's not a PNG anymore. You'll notice now we have this flag in the bottom right hand corner, but for some reason I just never resized the window, so I never saw that. I tried to open it up in StegSolve and opened it up in here, showing it now in the bottom right as well. I don't know why I took so long to find that, but there's the flag anyway. The next challenge is an exploitation challenge called Not So Complicated, and the description says use a memory dump from window panes to crack Jimmy's password, submit the flag as, and then give the plain text password. So we need to use our memory dump again. Let's go back over to volatility. And instead of running, we were looking at the processes last time and dumping out the processes at the end of the forensics section, but now we want to have a look at the hashes. So let's run hash dump, and this will dump out the various hashes. We need Jimmy's hash, which is right here, so we can run hashcat now. I would normally jump over to the Windows outside the VM to my Windows system because it's a lot quicker to run, but in this case let's set our mode 1000 for the Windows NTLM, and let's paste in the hash and use a share word list just because it's likely to be in RockU and hopefully not too far in it that we can crack it inside the VM, and we did. We got back our password quite quickly. So the flag is, oh god, I always do Control and V instead of Control Shift V. So that's our flag. The next challenge is called Old Devil. It's an exploitation challenge, and the description says, we found this program written by Luciafer. She used it to hide a password in the form of a flag. See if you can find the flag in the program. So we download the file. It's called daemon once we get it extracted and stuff, and it's a 64-bit LSB Pi executable, not stripped, which means we can have a look at function names and things like that. Might want to first of all just have a look at the strings in there to see if anything sticks out to us and see some potential input here. Need to enter a daemon's name, that's not the correct daemon's name, etc. Okay, so let's make it executable. Let's run it and just try and put in some input. Enter in hello, and we get that's not the daemon's name. Okay, let's try and run it with ltrace and see if it's just doing a simple string compare. So if we do ltrace daemon, you can see here it's asking us for a name. Just say hello again, and then we can see what's actually happening in the background. So it's doing a string compare between hello and Adramlek, and it's saying that because hello doesn't match Adramlek, then we didn't put in the right name. So we know that we can now run it again and just paste in that correct string, and we get back you are correct, and then it gives us the flag, which is basically the same thing but with some different capitalization and numbers and stuff instead. So we would just go and submit that. The next challenge is called Password Insecurities. It's a exploitation challenge, and the description says it looks like DeadFace is going after the password of one of Demon's customers, Haley Poitres. She has since changed her password, but Demon is looking for ways to improve password requirements. Demon would like you to crack the password from the database leak to determine if Haley's password was secure enough. Submit the flag as, and then the password. So we just need to crack the password, and we've got this SQL database dump to download. It's from another challenge. So we want to go and grab the hashed password, crack it, and see whether the password was secure. So I've got that file downloaded. Let's go and take a look at it. It's the Demon SQL, so I'm just going to open that up with Codium. And this is an SQL dump. Let me just go back there. File, Demon. Okay, it just shows ASCII there. I was wondering, is there some way to open this in a tool to get a better kind of look of it? Kind of like you would with SQLite browser. I've not used like MySQL Workbench in a long time, but I thought that whenever I last used it, you were able to kind of open dumps like this, or at least populate a new database with the same data just to make it a bit easier to go through. But what we'll try and do here is just search for Haley, and if we go through find Haley, did it give a surname? How many Haleys are there? Jerry Lee, Haley, Hodge. Okay. There's Poitras here, Haley. Okay, 7117. So I'm going to take a copy of this. I'm going to search 7117. And, okay, I'm going to get quite a few results. Let's match whole word. And then we're getting some credit card details and stuff. What we want to see is what's the hash that's linked to that. And here we've got a hash. Let's take a copy of that. And we could use hash ID here. Let's do hash ID. Let's paste that hash in. We just need to go and escape these $signs. And that'll tell us that the most likely hash type is MD5 crypt. So we could put this into a hash file. Let's do subl hash again. Paste this in here, and we could just use John again and say John -- word list equals user share word list rocku.txt and pass in the hash, and it'll just go ahead and identify it for us, and you can see it's come back and told us that the password is trust no one. We could also use hashcat for that, so if you go to hashcat modes, or just open up the hashcat manual on your terminal or hashcat help, you can go and have a look at the modes here and look for MD5 crypt. You can see that the mode is 500, so that command that we ran earlier, we ran like hashcat -m1000 for the NTLM, but we could do -m500. We could pass in that hash, and then we could do the same thing, user share word list rocku, and hashcat should also try to crack this. Again, it's a lot faster to do this outside of your VM probably, because you can use your GPU for cracking the hashes. Okay, I'm going to cancel it anyway. We've already got the password from Haley, so that should be fine. The next challenge is called You Shall Not Pass. It's a exploitation challenge, and the description says DeadFace has been targeting Demon employees based on the recent Demon financial database leak. Demon has already changed their employees' passwords, but they would like to try and crack the victim's passwords, see how secure it is, and what they can do to train their employees to use proper cybersecurity hygiene. So again, we need to crack a hash. Let's go and have a look at this ghost town thread that it's provided to us. And you can see that there's a post here saying that's a good idea. I'm sure they'll probably use the same password on and off work. We've got a post showing a poll where somebody's asking various questions, which could be answers to security questions or could be used in passwords. And the password we're looking to crack here was one from Merrily Lawless. So you can see that they've answered all of these questions. What street did they grow up on? What's their favorite TV show? What's their favorite color? What year were you born? So I am going to jump over to the Windows system to run hashcat this time, just because it is quicker, and I've got rule files and stuff on there. But basically we need to put together a word list of some of these. So what I did here was to take each one of these words, Goddard, Friends, Purple, Albany, Cashier, each one of them, and then obviously the date of birth as well, because it's kind of a hint that that's going to be used. And let's say our word list here is, so this is going to be our word list, and we're going to also use a rule which will go and basically try different capitalizations. It'll add like exclamation marks and underscores and things like that to it to try and crack it in hashcat. So let's jump over to the Windows system. Okay, over in the Windows system here, you can see that we've got our word list here, temp.txt, and it's filled with those words that we just went through. And we have our hash here as well. I forgot to mention actually the hash, that was from the SQL database dump for the user that we saw there, Merrily Lawless, because we weren't actually provided a hash with the question. So that's the hash that we've been given as well. And what I'm going to run here is hashcat.exe and then -m500, because it's the same mode that we just used to crack the MD5 crypt that we used in the last challenge. That's what the SQL database was using to store the hashes. And we want to provide then hashes. I need to stop using autocomplete because it slows things down. We want to provide a rule as well, so we're going to say rules, and then I'm just going to use one rule to rule them all, although there are quite a few different options you could use here. It wasn't a particularly complex password, to be honest, anyway. And then our word list, which is this word list here, which we've just manually compiled. So let's run through that. We can hit S to get a status, and we can see there time started 4 seconds. It's expected to finish in about 1 minute and 30 seconds. And there you go. You can see it's cracked the password. The password was sprinkles 1973 exclamation mark, and it cracked that in about 14 seconds. So then our flag is simply going to be flag sprinkles 1973 exclamation mark. The next challenge is called the root of all evil, or adding insult to injury, and the description says, great news, Luciafer has been spotted at an internet cafe. She's using a laptop right now. We can catch her if we act quickly. We need your help. Can you figure out a way to remotely connect to the machine and capture the flag? So we're told that based on the username of the system is Luciafer, and the host name is batescafe.deadface.io, and it tells us to use the PCAP from the traffic analysis challenges for this. So the first thing we probably think of here is to try and connect SSH Luciafer at batescafe.deadface.io, and we do that. We get permission denied. We don't have a key, but if we go to our traffic capture, as we were advised to do, I actually found by mistake earlier a private key in this, like on the first or second traffic analysis challenge. I'm not too sure where it is. Maybe it's in these commands at the end. Follow TCP stream. Okay, it's not in here. Let me go back. Okay, I think there's another stream then towards the end. Let's go towards the end here. Follow TCP stream. And this time we have, you can see that they actually ran cat and then printed out the ID, so the private SSH key for Luciafer. So we can take a copy of this. We can go and save this as our own key. We'll call this ID. Paste this in here. We need to change the permissions to 600, and then we can run this SSH again. This time use -I for identity, pass in the ID, and that gets us, we're connected. So we can have a look around here. We don't actually see a flag, but if we do ls -R for recursive and have a look in all these directories, we'll see that there's a flag in downloads. So let's go to, let's just print out downloads flag.txt, and now we have the flag for that challenge. The next challenge is called Monstrum x Machina or Machina. It's a traffic analysis challenge, and the description says, our person on the inside of Ghost Town was able to plant a packet sniffing device on Luciafer's computer. Based on our initial analysis, we know that she was attempting to hack a computer in Lytton Labs, and we have some idea of what she was doing, but we need a more in-depth analysis. This is where you come in. We need you to help us analyze the packet capture, look for relevant data to help to the potential attempted attack, to gather some information on the victim, investigate the victim's computer activity. The victim was using a search engine to look up a name. Provide the name with standard capitalization. Okay, so we've got this PCAP, it's already downloaded. Let me open it up in Wireshark. And one of the first things I normally do whenever I open up a PCAP like this is go and have a look. Well, we can have a look first of all at the file properties and get an idea how big it is, how long the packet capture went on for. So we can see here 161,000 packets nearly. It elapsed, it was a 15-minute packet capture. We can see the date and stuff like that. And we also can have a look at our protocol hierarchy and get an idea what kind of data we're actually looking at. So is there anything in here which is going to be of interest? Normally some things to look out for is going to be our HTTP data. You can see here we've got FTP data as well. So let's right click it, apply as filter selected. Let's close that down, and then we've got our FTP data here that we can go and have a look through. You can see they're retrieving a GIF or GIF file here, PNG file, we're retrieving some text files, encryption, some tools which are being downloaded, etc. So that might be a later part of the challenge. We know that in this case a search engine was used to search for something. So I'm going to set this to HTTP traffic and try and have a look. And actually, if we have a look here, we've got a search query. Let me apply this as a filter. No, not apply as a filter. Let me follow the HTTP stream. And if we do that, well, we have the username here in a couple of places in the search engine. So we can see that it was searched by Charles Geschichter. So that would be our flag. We would put in flag Charles Geschichter, and that's the first challenge. The next traffic analysis challenge follows on from the last one. It's called Sum of All Fears, and the description says, after hacking a victim's computer, Luciafer downloaded several files, including 2 binaries with identical names, but with the extensions .exe and .bin, so a Windows binary and a Linux binary respectively. What are the MD5 hashes of the 2 tool programs? Submit both hashes as a flag. This one took me quite a while because I misread the question. Let's go back to our FTP data that we were looking at in the last challenge, and we have some files in here. For some reason I thought it was talking about the secret decoder, so I was looking for an exe with the same name and I wasn't finding one, so I thought maybe the name wasn't there and I was trying to extract all different sorts of files. But obviously the answer is Lytton crypt. We have this, or Lytton crypt, sorry, or I don't know how to pronounce it, but we have a bin file, we have an exe file, we've got these both here, so we can go and follow the TCP stream of this, for example, and then we could set this to raw, and then we can save that. I can't even remember which one that was. Was that the bin? I think that was the bin. Okay, so let's say this is crypt.bin, save that, and oh, that was the exe. Oops. Let me go and rename that. Move crypt.bin to crypt.exe. And then the next one, we could also download these as well, by the way. You can go export objects, and or actually I don't think it doesn't give us the FTP options there, but you can export like HTTP objects and stuff here as well, and just save them all to a folder and go and look through the file types and things like that. Alright, so we've got our exe, we need a bin as well, so let's follow the TCP stream of this. Let's set it to raw again, and let's save it as crypt.bin. And now we have both files, so we can just go ahead and say md5 sum crypt all, and then we get both of them back. We just need to submit this as flag, paste in the first one, pipe, and then paste in the second one. And I believe that's what it was asking us for. exe, md5, and yeah, looks good. The next challenge is called Release the Crackin, still part of this PCAP file that we're looking at, and it says Luciafer cracked a password belonging to the victim. Submit the flag as, and then we need to submit the password. So we go back to our PCAP. If we have a look here at the FTP data, not the FTP data, but all the FTP stuff, you can actually see that they're attempting a variety of passwords here. You can see they've set the user here to the user that we submitted as being the potential victim previously, and they're trying a variety of passwords. Eventually you'll see that they get in with the password Dark Angel, so they cracked the password successfully and the password was Dark Angel. The next challenge is called Luciafer, you clever little devil, and the description says Luciafer gains access to the victim's computer by using a cracked password. What is the packet number of the response by the victim's system saying that access is granted? Submit the flag as, and then it asks for the flag with a packet number. I'm assuming it's talking about this user logged on. It doesn't say access granted, but this is where they were cracking the password. You can see they've been trying a variety of passwords with the username. Each time it says user cannot log in, and then the packet right after the entering in the correct password is user logged in, so 159765. If I go and try and enter in, it's just going to say it's already been submitted. This was actually submitted by my teammate, so I'm not too sure whether this 159765. whether it'll say incorrect. No, it just says you've already solved this. I think, unless I'm missing something, somebody can let me know in the comments. The next challenge is called Luciafer's Fatal Error, and the description says, Lucifer, consummate hacker, got cocky and careless. She made a fatal mistake, and in doing so, gave control of a computer to someone. She ran a program on a computer that she shouldn't have. What is the MD5 sum of the program? So we'll go back to our traffic PCAP, and let's go back to the FTP data that we were looking at. One of the previous challenges, I had got confused between Lytton Crypt and this secret decoder, which it looks like it's asking us to extract. So let's follow the TCP stream, and we'll set this to raw data again. Although, just before we do that, if we just go back to the... Where's ASCII? Oh, ASCII. Okay, so you can actually see this is a reverse shell, or a shell. Let's set it to raw. Let's save it as decoder, save it to the desktop, and then we just need to grab the MD5 of it. So we'll just do MD5 sum /decoder, and there we've got our flag. The next challenge is called Scanners, and the description says, Luciafer started the hack of Lytton Labs victim by performing a port scan. Which TCP ports are open on the victim's machine? Enter the flag as open ports separated by commas, no spaces, in numerical order. Disregard ports greater than or equal to this port number here, 16,384. So let's go back over to our PCAP. One thing we want to try and do here, first of all, let's jump over to the FTP data that we were looking at before, and let's try and find out what the attacker's IP address was. So let me go back towards the start here where all these passwords are being sent through, and you can see there that the IP address, the source IP address is ending 106, the destination IP address is 103, so our victim is 103 and our attacker is 106, so that's worth bearing in mind. We can go back here and have a look through some of the traffic, and basically this is some of the port scanning here, and we're getting some different results depending on whether the port is open or the port is closed. So what I'll do here, I'm going to set a filter up here, and you can see I've already got a filter set from previously. So we want to set and say the source IP address is 103, which is going to be the victim responding, and then the destination is the attacker, which we're sending the response to. If we go and do that and have a look through this traffic, we'll see most of these ports are coming back. You can see it's in red, and we have the we just have the REST ACK, whereas if we go down towards the bottom here, obviously we have some of our FTP data and stuff there, which isn't what we're looking for. Let's keep going. Keep going, keep going, keep going. Okay, let me go back to this, and we'll go up from here. So we do have some here that came through successfully. So you can see that the response has gone to say port 135 is open, or port 21, FTP is open. So what we can do is have a look and see how could we filter these then, and we could do that using the SYN ACK. So we can see here that in this example it's using REST ACK, and in this example we have the SYN ACK. So if the port is open, it's going to return SYN ACK. If the port is closed, it's going to return this REST ACK. So we can go here and we can actually say this SYN ACK, how do we filter by that? Let's go and say apply as filter selected. And we see here TCP flags equals, so this will select all of these responses where it's got SYN ACK. So let's go and use T-Shark to try and put some of this together. We can say tshark-r traffic, and that's going to read in our traffic.pcap. We can say that we want to extract, we're going to say fields, we want to extract the TCP source ports. And if you're not too sure what the syntax for some of these can be, just go back to, let's go and have a look here, where's our source port? We can go back and you can see here source port, you can go again and apply as filter, or you can add it as a column, and then you'll see the column here, and you can just right click here and you can see that, alright, it's TCP source port, TCP dest port, these are the values that we would need to put into T-Shark. So back over to this, we want to extract the source port, but we only want to extract the source port when certain conditions are met. For example, we want the IP source to be equal to 192.168. 100.103. We want the IP dest to be equal to 192.168.100.106, and we want the TCP.flags to be equal to 0x012. And then finally we want the TCP.source port to be less than 16,384. So that's all of the conditions met. We run through that, and we don't have anything set to only find unique values, so we would either need to put this into a text editor and just remove any duplicate values, or we can just go and read through them. I mean, we've got port 445, 3389, 21, 139, 135, 445, and it looks like the rest are just repeating. So we just need to go and plug those values in, and then we've got our flag. The next challenge is called a warning, and the description says Luciafer is being watched. Someone on the inside of Lytton Labs can see what she's doing and is sending her a message. One of them says, "Stay away from Lytton Labs, you have been warned." To find the flag, find the message. You'll know you see it when you see it. Alright, so we just go back to our PCAP. I actually found this one accidentally whenever I was doing the first part of this challenge. So I mentioned previously that we can go to export objects and export HTTP objects here, and it just so happened that, oh well, there we go, we can see the warning message. Let's actually go and take a look at it here. We'll go and follow this HTTP stream, and we've got the warning message.jpg is being loaded, and then we have this in the response. So alright, let's just go and export that. Export objects, HTTP. Let's go and, oh, we can preview it. Awesome. So we can just preview that, and we can see that our flag is flag angels fear to tread. The next challenge is called persistence pays off, and the description says Luciafer might have just bitten off more than she can chew. She has encountered an adversary that is counter-attacking the system, and it says Luciafer's Lytton Labs adversary execute a command to attain persistence on the computer. This command will allow the adversary to regain a connection to the computer again, even if she reboots it. What is the packet number where this command is executed? So if we jump back over to our PCAP and go to have a look through this, we want to scroll towards the end, I guess, and start having a look what happens after the shell is delivered. In fact, what I'm going to do, let's go back to our FTP data, and let's go and select. We know that the shell was delivered. It was a secret decoder bin because we got the MD5 hash of it. So now that that's selected, let's just remove our filter. That'll take us to the same place, and then we can basically go and start to have a look through what happened after that stage. We can see some TCP traffic here, and you can actually see the who am I command there. So let me follow this TCP stream, and we'll be able to see all of the commands that are entered here. So who am I, sudo -l, it grabs the decoder bin, and then you can see here that then this is being added as a cron job. So if we go and have a look at the packet number, it's 160468 is where the persistence is established. So we would just go and input that as the flag. The next challenge is called the Zealots Cryptoware IOC 1. And the description says the Zealots Cryptoware has a particular network signature. This can be used as an indicator of compromise, IOC. This indicator is unique to the cryptoware, so it can be used to indicate that a system has been infected by cryptoware, or cryptoware has attempted to infect it. So we've got a encryptor file to download. Let me go and take a look at that. It's a 32-bit LSB executable, and we can, let's make it executable. We might want to have a look for strings in there as well. It can be a good source of indicators. There's a way to use strings to extract network locators as well, but I can never actually find it in the documentation. I know I used to do it whenever I was doing some malware analysis stuff, but I've completely forgotten how to do it, and it's not in the documentation for some reason. Alright, so there's a lot of strings coming out here. We could try and do that again and grep for flag. And there is some mention of flags here, but it doesn't look like an actual flag. Okay, so what I'm going to do is try, and you notice it said there, it mentioned network indicator, didn't it? Network signature. Okay, so let's try and open up Wireshark to capture some of the network traffic, and let's try and run the program and see what the network signature is. So we'll run Cryptoware. We run that, you can immediately see some HTTP traffic. It's telling us all our files are encrypted, which I hope isn't the case. And you can see here it's getting the Zealot Crypt AES key. Let's go ahead and follow this HTTP stream. We follow it, and then we can see we've got this here. So we have some text here, Scooby Dooby Doo, but the indicator it was looking for here was the user agent. So you need to take a copy of this whole user agent and then submit it as flag user agent, and there we go. The next challenge is called Luciafer's Cryptoware IOC2, and apologies for probably mispronouncing whoever Lucifer is. And the Cryptoware causes even more ruckus by encrypting the victim's file names. Decrypt the file name and enter it here as the flag. So we have this encrypted file. This actually took me, well, it didn't take me a little while to do, but I wasn't too sure what it was talking about initially because I use wget normally to download these, and whenever you use wget, you can see there it just downloads. You can see in the bottom left we have 33E6T3XS, so I never actually got the file name in the name of the description here. So let's download that anyway. We'll move it from the downloads folder. What was it called? FK. Move that here, and let's have a look. So we've got a file name right here. We could go and throw this into CyberChef, which we haven't used yet. Paste this in here. You could just try and throw magic at it first of all, see if it can actually pull out any recognizable strings. It doesn't. What we might want to do is try and rotate this, because all of these characters are within a correct alphabetical range. So if we go through and start rotating them to see if any of these results make any sense, and as we start going through them, eventually we get to -3, Charles, a get sticker, to Dark Angel, and then the file extension is the L Labs. And so it's -3 or the same as 23 as well, both the same value. The next challenge is called Luciafer's Total Disaster. It's a reversing challenge, and the description says, Luciafer should learn to follow directions. Her cryptoware is a total disaster. She didn't realize that her choice of encryption algorithm, although a common encryption algorithm for hiding POCs from analysts because of its simplicity and lack of obvious signature, is terrible for cryptoware. Do some basic analysis on a malware and see what information you can come up with. There are some great easy to use tools that can help a burgeoning malware analyst. Alright, so we've got this file downloaded. It's been part of a couple of the challenges now so far, and some hints here as to look at some malware analysis platforms here. So the first thing that I did was go to VirusTotal and upload the binary, which we have here. We can go and have a look at some information about it. Where's it detected malicious? We can go and see if the file was renamed, what sort of DLLs it's using, what imports, functions, things like that. You can see here the URL, where the URL came from, or the URL that's contacted by it, which maybe will come in useful later. And we also have this community tab, which if we go and have a look at, has this message, Happy Halloween and congrats on finding the flag. And there we have the flag. The next challenge is called Serial Killer. It's a reversing challenge, and the description says, Spooky Boy is really into his serial killers. He loves to watch Mindhunter on Netflix. He can also slay a bowl of his favorite cereal. So we can choose in this case whether we want to download a Windows binary to analyze or a Linux binary. I chose Linux because I'm not a sadist. And we can have a look at the strings of the serial binary again, just to see if there's anything sticking out, any passwords. You can actually see that we've got this fake flag in here this time. And you can see it's going to ask us for a passphrase. In fact, it looks like it's asking for a passphrase, and the passphrase is right below it. Let's see if that's the case. I'm going to make it executable, and let's run it. Let's enter in that passphrase, and there we go. We get back our flag. Alright, so in that case strings did it for us, but let's just assume that the password wasn't sitting right there in the strings. Let's run GDB. I'm using a Pwn debug plugin here. Open up serial, and if we do this we can have a look and see what functions are available to us. We've got our main function here. Let's try and disassemble main. Disassemble main, and we can go in here and try and have a look what's actually happening. One thing we'll note is that at some point we have these hex values being moved into the RAX. And do we have some more hex? We've got some more hex values down here. Let me go ahead and we'll do that pwn unhex. We can actually do that inside of this, so we can use that inside of pwn debug. Pwn unhex, paste that in, and you can see here it's in reverse order. So you can see we've got this count, and it's going to be chocular or whatever it was next, but in reverse order. We could take some of this as well and do the same pwn unhex, and yeah, so that's some more of the flag. But obviously that's a bit hard to read and decode. So what we might want to do in this case is look for the well, we could set this to, let me set a breakpoint here. Let's first of all break main. Let's run the program. Let's again disassemble, see where we're at. We can disassemble right here, and I'm going to set a breakpoint. Break star 0x. Let's continue the execution. It's asking us for a passphrase, just say anything. And whenever we hit this breakpoint, you'll see that we've actually got our flag in the RSP. And we can see it that it's sitting here on the stack. So just if we assumed that this challenge was a little bit more difficult and that the password wasn't sitting in the strings, this would be another way to have a look and see what's actually being loaded onto the stack. The next challenge is called Serial Killer 2. It's a reversing challenge, and the description says, Morticia loves spooky, sugary cereal. She isn't scared of hyperactivity or tooth decay. Download the program and decrypt the output to see what her favourite cereal is. And we've downloaded the file. Let's go and take a look at it. In this case, it's a Windows executable, so we're going to have to swap over to Windows here. We could open up Geardra and go and take a look at the code here, and we could still do our usual trying to get a quick, easy win with strings and things like that, but we're not going to see too much in this case, and the reason being, we can actually see some functions here, but the reason we're not going to see too much is we need to go and try and decompile this. It's a .NET assembly, so unlike typical Windows or Linux binaries, we can actually go and get a good copy of the decompiled code if we go over and use a tool like dnspy. So I'm going to jump over to my Windows VM here and we'll go and have a look at it. So I'm over in the Commando VM here. This is just a Windows VM, which is kind of designed to be like a pen testing distribution. It comes with quite a lot of different tools installed for well, I've added on a lot of tools here as well. It's not really aimed for kind of malware analysis and forensics. It's more focused on red team stuff, but it comes with quite a lot of tools installed, and it's quite easy to go and install new tools here through the box starter shell. So if you're interested, if you need a Windows VM for working on CTF or pen testing stuff, this might be worth looking into. And we've got our Serial 2 here. What I'm going to do is go and let's go back to our tools here. We've got in disassemblers, nope, not disassemblers, in .NET, we've got dnspy. So I'm going to open this up in dnspy because we know it's a .NET assembly, so we're going to be able to just go and have a look at the code. Let's drill down into this. We've got this symmetric encryptor, and here's our functions. So we've got a main function right here. I'll try and zoom in on some of these windows. Get rid of this. We have a main function here, and you can see it's doing console write line, and we have this base 64 encoded value, what looks like a base 64 encoded value. We've got another function get key, which is going to take a password, and it's basically going to generate an MD5 of that password. We've got encrypt string, so that's going to use, I guess, a key, and we have some decimal values here, and it's going to perform some encryption. We have decryption, which is going to do the same thing, well, a reverse obviously, and we have this decrypt from base 64 string. Okay. The other thing we have here is this flag. You did not think it was that easy, did you? Password, and that's it. Okay, so we can see this is an AES decryptor, and if we have a look at the decryptor here, just highlights it, you can see that it's taken in RGB key and it's taken in RGB IV. And what it's actually being passed here is the array in both instances, and then it's going to perform the encryption or perform the decryption. And this is our array right here. So I'm going to take a copy of this. I'm going to go to we could actually probably just run this you could modify this code to, rather than doing console.writeLine, you could set it to call this decryptor, but that's not the way that I solved it. I'm just going to show you the way that I solved this instead. I'm going to go to the good old CyberChef and use the AES decryption in there. So let's first of all paste in our base 64. Oh no, wait, that's our decimal values. That's fine. Okay. Let me just clean these up a little bit. I'm looking to remove space in here. Remove white space. Okay, nice. Remove white space, and then let's convert from decimal. Okay, and then let's do 2 hex. Oh. There we go. Okay, looking good. And then let's say we don't want any spaces here. So we've just converted these decimals into this hex value. Now what I'm going to do is I'm going to get rid of all that. I'm going to create a new recipe. I'm going to say AES decrypt. And as our key, we're going to put in that value. And as our IV, we're going to put in that value, because we can see that they're both it's taken in the same array for both values. Actually, at the beginning, what I thought was happening was, because we have this password which is set to this fake flag, and then we have in our get key, it's going to take in a password and generate an MD5. I thought that what we needed to do was MD5 the password, the fake flag, and then use that as the key, and then use the IV as these values here. But it seems that they're just taken in the exact same array, so the MD5 and the fake flag and stuff is just completely irrelevant by the looks of it. Okay, so let's grab our base 64 encoded value, and we'll go and say this is what we want to decrypt. We want to make sure that we set our input to, let's set our input to raw. We need to convert it from base 64. From base 64, and there we get back our flag, Frankenberry, goodness, nom nom nom. The next challenge is called Serial Killer 3. It's a reversing challenge, and the description says Luciafer also has a favourite cereal. It is spooky and very delicious. This one, however, is a bit tricky. Download the program and decrypt the output to find out what her favourite cereal is. And again, we've got a Windows and a Linux binary this time, so I've downloaded the Linux version. And we can have a look. Let's check the file type first of all. It's a 32-bit binary. We can have a look at the strings, see if we've got a password or a flag sitting there. And we don't appear to. We've got a fake flag, but it doesn't have a... And we have what looks like, you can see here, that kind of looks like parts of a flag that maybe need to be reordered or, I guess, decrypted in some kind of way. So let's make this executable. chmod plus x serial, and let's try and run it. Asks us for a passphrase. Okay, we put in the wrong one. Let's try it with ltrace as we did earlier to see if it's doing a simple string compare, and it's not. We can't actually see anything here at all this time. So I'm going to open up a new project in Geardra. This takes a little while to create, so I'll speed through the process a bit. Unfortunately, the audio for the rest of this challenge didn't record, so I'm just going to try and describe it as I remember. So I'm just describing here. We've got Geardra open, we've got a decompiler, we've got our disassembled code, we can access our .data section and stuff like that in the program trees. We've got our symbol trees with our imports and exports and functions, and we go to our main function to try and work out what's going on in the code. And I'm just kind of noting here that the code looks quite complex. If we were to try and statically analyze that, we could do it, but we'd need to probably go through, rename a lot of variables, and step through the code line by line to work out what's going on. But we have at the bottom here a condition which is saying if ivar3 is equal to 0, do something. Otherwise, it's going to do something with this not flag. You guessed it again, this is not the flag. So I'm just going here to verify that if we enter in the wrong password, we get that message to say you guessed it. So we have a couple of options here. We could just basically patch the binary so that if we enter the incorrect password, it'll do the opposite thing, change that condition. Or we could run the program and set it to jump to a different address, jump to that function rather than jump to the function that prints the incorrect flag. And at this point, so just decide that we'll be better off going over to GDB to demonstrate that. So I try to open the program, fail, try again, fail, third time's the charm. Info functions, so we're just going to have a look at the main function I guess here, try and find out what the address is that we're interested in. We have the string compare, which is going to be comparing our password obviously, so that's of interest. Set up a breakpoint here, run the program, and then we'll go and set up a breakpoint at the string compare. And we run the program again, we see that we've got a passphrase, a password in the sitting in that as a parameter ready to be passed for the string compare, so it's being compared. You can see the A in the first parameter and the boo boo berry in the second parameter, so we just go and try and run the program again, pass that in as a password, and that will get us the flag. The next challenge is called The Zealot's Fingerprints Are All Over This. It's a reversing challenge, and unfortunately the competition ended yesterday. I didn't actually realise, I thought it was still running today, so I didn't get a chance to record a couple of the write-ups, but luckily I still have the files from this challenge and a couple of the others, so I'll run through those now. In terms of this challenge description, essentially it was letting us know that there's two decryptors, which are from this challenge here, the Decrypting Lytton Labs number 2. There's an encryptor and a decryptor, and there's an encrypted file as well. And for this fingerprints are all over it challenge, we were just asked to go and get the SHA-256 sum of the encryptor and the decryptor. So we can do SHA-256 sum, and then we'll say all cryptor. We get our 2 hashes, and then the flag was just like flag. We enter the encryptor, and then piped in the decryptor. The next challenge is called Decrypting Lytton Labs Cryptoware 1. I can't view the description because the competition's over now, but essentially we were given a Windows binary and a encrypted document, and we were told to go and try and find a way to decrypt the document. So I still have the files, luckily, so I'll be able to walk through the solution, which I didn't actually get to solve, but I'll step through where I was going with it and how we could have actually solved it now. So I'm just going to jump over to the Windows system. So we've got our Zealot Crypto exe, we've got an encrypted file as well, and I've opened this up in IDA Pro. I spent quite a while trying to solve this challenge using Windows debuggers. Let me see here, we have Ollie debug, Win debug, X32 debug, Immunity. Obviously I'm just terrible at using Windows debuggers because I was struggling to even get to sections of the code that I wanted to set breakpoints at and stuff. But if we have a look in here, let me search for main in IDA, and we have a main.main as we do in our other encryptor. We have a encrypt RC4 and our fetch key. We're unable to decompile this. I think, oh, we are able to decompile it, okay. So F5, you can use the decompiler to have a look at this. And what I did notice this time is in our fetch key, we have this SHA-512 sum. So in the other decrypting challenge, which you'll see after this one, if you're watching the video in order, we have an MD5 sum here. So I thought it was going to be something kind of similar. Let's go and open up Wireshark and see if there's something similar going on with the network traffic. Let me try and find it. So we'll open Wireshark, start capturing on the Ethernet, and then let's run this encryptor. We should get a message. Oh, it just closes down after the message, that's fine. But that runs through, and basically we have a GIF which is sent, and if we follow the HTTP stream, you can see the GIF here. We can save as, let's go and file export instead, export HTTP. We have this image called prettylady.gif. We can preview it, we can save it, and this is the image. So I downloaded this and I took a SHA-512 sum of this and tried to use that. Thought we'd be able to use that to decrypt, but apparently that was possible. Looking at an official solution, you could get the 512 sum, but then you also needed to extract certain parts of that 512 sum to be used as the key. An easier way to solve it would have been to notice that, and I did notice that the RC4 is just an XOR stream. So if we were able to get the key, we'd just be able to go to CyberChef and select the RC4 algorithm and then apply the key. It was just finding that key that was the difficulty for me, but we don't actually need to find the key. So there was a flaw in the program, meaning that if the file extension was changed, so in this case the file extension is 000dev, in our in the next version of the crypto we have a decryptor and an encryptor file because it's using AES, and a separate encryptor and decryptor is needed. But in this case it's RC4, so it's basically a reversible function, which means if we run this encryptor with a different file name, so if we set the file name to, I believe it's LLabs, and then run this program again, it should just decrypt the file, and it does. So, well, it's technically encrypted the file. It's turned it from LLabs to OODev, but because it's a reversible function, that's actually decrypted the file. So we got back our flag, which is saying that RC4 is a reversible, but AES is not. Go back, go back. The next challenge is called Decrypting Lytton Labs number 2, and it's similar to the first one, which was a Windows version where we just had an encryptor file and an encrypted document. In this case we've got an encryptor, we've got a decryptor, and we've got an encrypted document, so we'll go and take a look at those. I can't remember exactly what the challenge description was, and the competition's over, so it won't let me view it, but let's go and run through the challenge. So if we have a look at the files available to us, unlike the first version of this challenge, we have this decryptor file, so let's just go ahead and try and run it first of all and see what we get. We get a message saying we need to enter the key as a 32 character hex string. So we might want to go and take a look at some of the code. I've got this open in Geardra already, so I've loaded the encryptor and the decryptor. So we could go and start having a look through some of these functions. You will see quite a lot here, so if you just search for main and then focus on the main.main, and we've got main.find files, main.rotate text. For some reason it's not giving me a decrypted function there. Let me go and check the encryptor. Let's go and have a look at the main here. Main.main. Okay. Let me go back to the decryptor. Alright, it's just taking a little while to load. So yeah, the decryptor here, you can see we have some similar functions. We've got a main.rotate text, main.main, main.find files with extension, and we have the decrypt AES. It looks like there's just quite a lot of code in here. You can see it's still trying to process all of this. Let's go back to our encryptor and have a look at this main.fetch key. So this is what I was particularly interested in, trying to work out what's going on here. I had a quick look in here and figured it would probably be easier to determine what's going on through some debugging rather than static analysis. So let's go and set a breakpoint on this for the encryptor. If we open this up in GDB, pwn debug, encryptor, and let's set a breakpoint at main dot, and we could set a breakpoint at a few different ones here. We could do the find files with extension if we want to try and find out what type of files it's focusing on encrypting or decrypting. In this case I'm going to set the breakpoint on fetch key, and let's run the program. Run the program, we hit our breakpoint, which is awesome, and look what we see here. We see HTTP Insidious DeadFace.io and the Zealot Crypt AES key. So it looks like a connection's being made to this HTTP site. We could continue to step through this to see what it's actually retrieving, and that should get us some information, or we could go and have a look at the actual network traffic. I think we saw this earlier on another challenge anyway. Oops, let me exit that. Let's open up Wireshark. Let's start capturing, and then I'm going to go and run the encryptor. We run the encryptor, we quickly will notice some HTTP traffic in the background, so that's good. Let's stop the encryptor, let's follow the HTTP stream of that zealot crypt, and that's where we see that the key here is Scooby Dooby Doo. Obviously that's not 32 bytes of hex, but if we go and let me see if we can just convert this here to hex, convert that to hex, and then we now have 32 bytes. So we could try and let me close down some of these windows. We now have a 32 byte hex string, so that's what it was asking us for with a decryptor. Let's paste that in, see what we get, and we get an error saying authentication failed. So maybe the key isn't correct. And it was at this point that I noticed in our fetch key stage, I think it was in fetch key, yeah, in our fetch key stage we have this crypto MD5 sum, and that's when I was thinking, well, maybe rather than just converting it to hex, we actually need to get an MD5 sum of that Scooby-Doo string. So let's try and do echo-n. You need to do -n to get rid of the new line, and we put in that Scooby Dooby Doo. We'll echo that at MD5 sum and get this MD5, and then let's try and run it again. The decryptor, provide that value, and then we have this Dark Angel to Charles. I don't think I actually showed there before, so this was set to .oo.dev, I think it was, which was the encrypted file extension, and it was an encrypted file, and we've now successfully decrypted that file. I should have actually shown that was encrypted to begin with, but you just have to trust me, it was encrypted. We've now decrypted it, and we've got our flag. The next challenge is called Send in the Clowns, and it's a Stego challenge. The description says, there is a secret hidden somewhere in this image, can you find it? So we've got a JPEG image which has been downloaded, this clowns.jpg, and it does look pretty scary actually. First thing we want to do is have a look at the strings. Let's do strings greater than 10, and we do that and we very quickly find our flag. Our next challenge is called Scary Bunny. It's a Stego challenge, and it says, what could be inside this creepy rabbit? We've got this image to download, and again the first thing I did here was the usual, let's look for strings -n10. Let's open up StegSolve. We could throw this into CyberUp or something as well. It's really good for image analysis and extracting bit planes and embedded files, etc. I was going through this. I did actually notice on the 0 planes we always have this little square in the left. Let's go to the green one as well. Same. So I was trying to extract that. It wasn't the solution anyway. We need to go back and let's try and do steg hide. I tried doing steg hide, so we can say steg hide extract -sf bunny. I tried doing this with bunny, evil, rabbit. What else did we see in the description? Creepy. None of them worked. Let's try it without a password, and this time we get our payload, which is the flag. The next challenge is called Behind the Curtain. It's a Stego challenge, and the description says, this image was intercepted from Ghost Town. We think Donal has hidden information here, but there doesn't seem to be anything special about the image. Can you help find the hidden information? So we've got a file to download, a JPEG image. What I didn't notice whenever I was doing this challenge initially was that it has this link to the forum post as well. So we have this image. How's this one? I hid one of my passwords in it. I'll make sure to change it later though. And then somebody says, could be better in my opinion. And the way you hid that was easy to find. But then again, most people would try to use steg tools, which probably wouldn't work too well for them, lol. So we have the same image here. That's what I initially did try. I tried to open it up in StegSolve, and let's just do it anyway. Open it up in StegSolve, go through and have a look at the different planes, and we can go and have a look at the spectrogram and things like that, try and extract data. Obviously it didn't get me anywhere because I didn't see that forum hint, but what I had initially tried to do before even actually opening it in StegSolve was to run foremost. We run foremost against curtain.jpg and then list the output. You'll see here, I saw here basically the JPEG folder and then just moved on. But if we were to try and do something similar with binwalk, which will basically do the same thing, we'll actually see that it extracts 2 JPEG images. So I should have been a bit more careful originally and actually gone and had a look at this JPEG folder, and then I would have noticed that there's actually 2 JPEG images. So let's go and take a look at them. And yeah, we've got basically an image inside an image, and one of them has the flag in it. The next challenge is called Voice, and the description says, a friend sent me an audio file which is supposed to tell me the time of our night out meeting, but I can't comprehend the voice in the audio file. Can you help me figure it out? I want to hang out with my friends. So we download the audio file. It's a .wav file. I'm not even going to open it and play it, but let's run strings-n10 on voice. We don't find anything of interest. We could have a look at the EXIF data, and again, nothing of interest. We could run foremost and see is there anything inside there to extract. And nope, we've just got a WAV file. So I'm going to open this up in Sonic Visualizer, which is quite often a useful tool to find hidden data in audio files. We'll open up, where is it, desktop, voice, and zoom in a bit here. And basically we want to go and try and do add some different things here. We can add a waveform, we can add spectrogram. Let's do the waveform first of all. Didn't do much. Let's do the spectrogram, all channels, and there we get our flag. So flag 1257. The next challenge is called No One Ever Got Fired For. It's a Stego challenge, and the description says, but they should have. We spent $20 million for this refrigerator-sized box, and we have to pay money for every program we run. And then when we try and pull data off, we get garbage like this. No one can read it. None of our standard Windows or Mac OS X systems can read this junk. We can't even figure out what it's supposed to be. What do you think? Can you help us? Enter the flag exactly as it appears in the file. So we got this file to download, which I've downloaded and got a copy of here. I've just called it can't read. You can see it there. So we can try and run strings-n10 can't read, and we won't see anything of interest. We can have a look at the file type, and again we won't see anything. We could try and run foremost and things like that. What I'm going to do is jump over to CyberChef, and let's load the file in here. Whenever I was actually testing this, I tried to open the file and use a text decoding brute force option. You can see here decode text, and this allows you to specify an encoding. You can already see how slow this is going to be because of the size of the file. We have various encoding types here, but what I was trying to do is brute force, text encoding brute force, and you can set it to decode and try and get it to decode each one. What we could also do to try and is go and have a look at some of the hints that we have available to us here. So the name of the challenge is No One Ever Got Fired For. If we go and search that, we'll find that nobody ever got fired for buying IBM. You'll notice that whenever we were looking at the text encoding options here, quite a lot of them start with IBM, which is interesting. Let me just cancel this because we can see already how slow it's going to be. Let's search for IBM text encoding, and we'll see some information about this character set then, and it gives you some examples of comparing some ASCII strings to these IBM strings using their character sets. So here's some examples showing how the binary is different for the same characters depending whether you're using ASCII or EBCDIC. So let's go over to our CyberChef, which is apparently just completely given up now. Yep, okay. Let's close that. Let's start again. And let's open our file here. Can't read. Let's just go straight to decode text. Let's set this to IBM. I don't know if any of these matter too much. I'll set it to UK just because that's where I am. Let's go strings and look for strings greater than, say, 8 characters. And look what we find. We find build PCs with Linux instead. So if we go back over and submit our flag as flag build PCs with Linux instead, we'll get our challenge complete. So we've covered about 40 of the challenges here anyway, varying in difficulties and from a couple of different categories. I would have run through a couple more to be honest, but the files are no longer available. I can't click on anything or access the challenge descriptions or anything, so maybe they'll make those public, but I guess the video is getting pretty long anyway. Some thoughts. I had Burp Suite open this entire time and there wasn't a single web challenge. I apologise for anybody's name I butchered, probably Luciafer's or Lucifer. Luciafer. I don't know how many different pronunciations I've had of that throughout this video. Yeah, I wish that CTF competitions would keep up the challenges or keep the files or descriptions available for after the competitions ended so that people can do walkthroughs. I kinda try to make these video solutions as I'm going, because otherwise I'll get to the end of the competition and be like, I'm not gonna record 50 challenges now, so I'll do it as I go. You know, I might solve 5 or 10 challenges and then go and record a few and then go and solve some more, etc. But I hope you've enjoyed this video anyway. If you have any questions or comments, anything you solved differently or anything I missed, you can let me know in the comments below.